These are your notes for Chapter 6, Section 9. The essential question is, how are conics in polar form graphed? Okay, eccentricity. The locus of a point in the plane that moves so that the distance from a fixed point is in a constant ratio to its distance from a fixed line is a conic. The constant ratio is your eccentricity. We use eccentricity to determine what type of conic we have. If the eccentricity is less than 1, you have an ellipse. If the eccentricity equals 1, you have a parabola. If the eccentricity is greater than 1, you have a hyperbola. Okay, polar equations. Oh, and the focus is always located at the pole. Polar equations of conics. E stands for eccentricity, as stated above. And eccentricity is always greater than 0. P is the distance between the focus and the directrix. Okay, we have two equations for conics. The first one is R equals EP over 1 plus or minus R cosine theta. And the second one is R equals EP over 1 plus or minus R sine theta. Okay, I want you to notice the 1 here and here. This is very important. We're going to be using that as we graph our conics. Okay, looking at the first equation. As I said, the 1 was very important. Notice that in the same location in this equation, we have a negative 1. So that means I have to multiply numerator and denominator by negative 1 so that we can get it in standard form. So R equals negative 5 over 1 minus 2 cosine theta. And this is the equation we're going to be using to plot our key points. Okay, so we're going to set up an R theta chart. We use the angles that divide up the quadrants. So my first angle is going to be 0. If I plug 0 in for theta, cosine of 0 is 1. 2 times 1 is 2. 1 minus 2 is negative 1. Negative 5 divided by negative 1 is 5. And then we're going to go over to our graph. I'm going to count out 5. 1, 2, 3, 4, 5. There's my first key point. Okay? Next point. Use the angle pi over 2. Cosine of pi over 2 is 0. So I end up with negative 5 over 1, which is negative 5. Okay? Instead of going up for pi over 2, I'm going to go down. Right here. Okay. My next point I'm going to find has an angle of pi. Cosine of pi is negative 1. Negative 2 times negative 1 is positive 2. 1 plus 2 is 3. So this is going to be negative 5/3. So instead of going left, I'm going to go right 1 and 2/3. Right about there. Okay, last angle. Last angle is going to be 3 pi over 2. Cosine of 3 pi over 2 is 0. So that's going to be negative 5. So I'm going to count up. There's my other key point. Okay, I'm working with a hyperbola. Because it's cosine, I know it has symmetry along the polar axis. So this has to be my hyperbola. Okay, so now we'll go to the second page. We'll look at those examples. Okay, if you notice, example A is in standard form because the 1 is positive 1. So I'm going to set up my R theta chart. Once again, we'll start with 0. Sine of 0 is 0, so that gives me 3. So I'll plot that one. Next one is pi over 2. Sine of pi over 2 is 1. 1 plus 1 is 2, so that gives me 3 over 2. So I'm going to go up 1.5. Okay, my next angle is pi. Sine of pi is 0, so once again that gives me 3. And then my last one is 3 pi over 2. That is negative 1. So 1 plus negative 1 is 0. I get 0 in the denominator, so I don't have a point for that. Now I'm going to sketch my parabola. Looks like that. And it should have an axis of symmetry at theta equals pi over 2. Okay, next problem. Another R theta chart. First angle is 0. Cosine of 0 is 1. Oh, let me back up. Notice that the 1 is in the correct position and that my eccentricity is 1 because eccentricity has to be positive. So that means this is also parabola. So cosine of 0 is 1. 1 minus 1 is 0. So I don't get an answer for that one. Pi over 2. Cosine of pi over 2 is 0, so I get 6. Next one is pi. Cosine of pi is negative 1, so 1 minus a negative 1 is 2, so that gives me 3. And my last one is 3 pi over 2. See if I can squeeze that in here. 3 pi over 2 is 0, so once again that's 6. So let me back up. I have no point for the first one. I have 6 for pi over 2, which is right there. I have 3 for pi. And I have 6 for 3 pi over 2. So here's my parabola. And it does have an axis of symmetry along the polar axis. Okay, problem C. This one is not in standard form. I need a 1 in the front in the denominator, so I have to divide everything by 3. So I get r equals 3 over 1 minus 2/3 cosine theta. Okay, that means that this is an ellipse because eccentricity is less than 1. Okay, we're going to set up my r theta chart. Okay, so we start at 0. Cosine of 0 is 1. So I have 1 minus 2/3, which is 1/3. Multiply numerator and denominator by 3, and I get 9. Okay, so 0, that's going to be out here, unfortunately. Okay, pi over 2. Cosine of pi over 2 is 0, so that's 3 over 1 and 3. Okay, then we have pi. Cosine of pi is negative 1. So that makes this 1 plus 2/3, which gives me 5/3. And I end up with 9/5, which is 1 4/5, about here. Okay, one more. 3 pi over 2. 3 pi over 2 is 0, so I get 3 again. Okay, so my ellipse looks something like that. Okay, I suggest you pause the video and get this copied down because I'm going to have to erase it to do the last problem. Okay, we got it erased. Okay, so notice that problem D is not in standard form. So I have to divide by 2, numerator and denominator. So I end up with r equals 1 over 1 plus 3/2 sine theta. Okay, so I'm going to set up my r theta chart. My first my first theta is going to be 0. So sine of 0 is 0. I end up with 1 over 1, which is 1. Oh, and by the way, this is going to be a hyperbola because my e is 3/2. Okay, then I do pi over 2. Sine of pi over 2 is 1. So I end up with 1 plus 3/2 in the denominator. So that's going to be 5/2. 1 divided by 5/2 is 2/5. That's really close here. And let's see. 1 0. That's like right here. Okay. So, pi. Sine of pi is 0, so I get 1 again. So that's right here. And then my last one is 3 pi over 2. 3 pi over 2 is -1. So that makes this -3/2 over 2, so that's going to give me -1/2. I flip it and I get -2. So this is my hyperbola right here. All right. Go ahead and do the try me questions, and then you can start on your assignment.